So we will begin with a short video, which is a tribute to where we are.
One of Aristotle's most famous contributions to science is actually based upon a false claim. For years, Aristotle preached that heavy objects fall faster than lighter objects, stating that the speed at which something falls actually depends on its weight. He would explain it to anyone that would listen. His example was that an object 10 times heavier than another would have to fall 10 times faster. No one disagreed with Aristotle. Most people were comfortable with the idea of heavy objects falling faster because that's what they were used to seeing. For almost 2,000 years, Aristotle's rules for falling objects remained unchallenged until a new scientist attempted to prove him wrong. In the year 1589, an Italian scientist named Galileo attempted to prove Aristotle wrong. Galileo believed the only reason heavy objects fall faster is because air resistance slows down lighter objects, and that if air resistance could be reduced, they would both fall at the same speed. In order to prove his point, he gathered everyone in the city, climbed to the top of the Leaning Tower of Pisa, and explained that the only way to prove who was right for sure was to perform a scientific experiment. Galileo's experiment went like this. He stood at the top of the Leaning Tower and held out a cannonball and a wooden ball of the same size. The only difference between the two objects was their weight. Galileo explained that since they are the same size and shape, they would feel the same amount of air resistance as they fell. His conclusion was that they should hit the ground at the same time. So he leaned out over the edge, dropped both objects, and a little more than 3 seconds later, everyone in the city of Pisa saw the cannonball and the wooden ball land at the same time, proving once and for all that if there is no air resistance, all objects, no matter how heavy, will fall at the same rate.
So to sum up this kind of poor video, Aristotle believed that heavy objects fall faster than light objects. His intuition, shared by many to this day, held up for 2,000 years. Galileo proposed an experimental method, and he dropped two balls of the same shape but different weight, and everybody saw that they fell at the same time. And we now know that free fall speed is not dependent on mass. And I will, of course, explain what this video has to do with the topic of my talk, but I will get to it at the end. So the field known as behavioral economics was born when Richard Thaler, an economist, met Daniel Kahneman, a psychologist, at the second half of the 1970s. They are widely regarded as the founding fathers of behavioral economics and have 2 Nobel Prizes in economic science to attest for it. But in the lay public and in the media, behavioral economics is often confused with psychology, and I get called a behavioral economist a lot, but I am a psychologist, not an economist, and therefore I don't call myself a behavioral economist. Not that any of this really matters much. Behavioral economics is doing economics with the realization that human economic agents are human, made of flesh and blood, and subject to all the foibles and weaknesses of flesh and blood. And just doing economics with that in mind makes it behavioral economics. Now, historically speaking, the early giants of economic thought explicitly acknowledged that certain kinds of economics relied on psychology. We can have the next slide now. They even formulated some of the specific insights that were later rediscovered by experimentalists. And you can look at the slide. I will go on. I will not read it for you. Now, psychology has always been embraced by neoclassical economics. Indeed, the very core concept of utility acknowledges psychology in 2 ways. First, utility, that variable which economic agents want to maximize in their choices, is not necessarily linear with the variables on which it is defined. Indeed, this is money, and this is utility, then the relationship between the sensation, the objective value of money and what it does for you in terms of utility, it looks like this in economics, and this is a typical psychophysical function. Psychophysical function is, of course, psychology. The second sense in which utility acknowledges psychology is that utility acknowledges individual differences. It's not a one-size-fits-all function, but rather different people have different tastes, different preferences, different abilities, different beliefs, different expectations, all of which has always been recognized by mainstream economics. But in spite of acknowledging all of these individual differences, there is one variable that economic theory has always insisted is shared by all economic agents, and that is rationality. Now, what is rationality? There is the technical sense, and there is the everyday sense. We can have the next slide now. In the technical sense, rationality is first and foremost consistency. First of all, your preferences have to be consistent with each other, such that, for example, if you prefer A to B and B to C, by consistency, you should prefer A to C. Second, to be rational, you have to always be rational. It is not the case that to be irrational, you have to always be irrational. Think of an attribute like honesty. To be an honest person, you have to always be honest. To be a dishonest person, you don't have always to be dishonest. It's enough that you are sometimes dishonest. So rationality requires two kinds of consistency. Consistency of your preferences and consistency over time and situations in this being consistent. And now another psychological insight that was readily embraced by neoclassical economics, and indeed also won a Nobel Prize in economic sciences for the person who put it forth, is that of Herb Simon, a Renaissance man whose work influenced not only psychology, but economics, computer science, political science, and much more. And Simon pointed out that people couldn't possibly be as rational as required by economic theory because human beings are limited beings, or what he called bounded beings. They have limited time, limited memory, limited cognitive capabilities, limited energy, sometimes even limited motivation. So he introduced the notion of bounded rationality and said that people do not necessarily optimize, in other words, do the best, but rather they satisfy, in other words, do something that is good enough. But within the limitations that Simon pointed out, people were still required by his theory to be rational, to be consistent. In other words, boundedness is no excuse for being capricious. Now, many other psychological insights have found their way over the years into mainstream economics, but the standard way that this would unfold is as follows. Somebody would point out, and in the good cases with experimental backup, a counterexample to one of the axioms, and an economist would say, well, in that case, let me introduce that finding, that variable, into my mathematical model, which is the favorite way of doing theoretical economics. And as long as they could model it, they were perfectly willing to embrace it. For example, take the finding that people are myopic, that their ability to look ahead, plan ahead, and know how they are going to feel ahead in the future can be quite readily embraced in a standard theory, because economists have always known that time is money, and they have no problem handling the fact that utility gets discounted over time. Now, in the 1940s, von Neumann and Morgenstern offered a mathematical axiomatization of utility theory under risk. And they laid down a small number of prima facie natural and self-evident requirements of consistency, such as the transitivity requirement I mentioned earlier. And they proved that if a person were consistent in the sense required by these axioms, then one could fit a utility function to that person's preferences, and choice would always be maximization of that utility. Now, the axioms, I will not go through them now, but first and foremost, the axiom required the individual to order the certain outcomes from best to worst. Now, take, for example, because it's the prototypical example, take money. We can certainly, it certainly seems natural to order money by monetary size from best to worst, but I can show you immediately that even that you can find a counterexample to. Take something as simple as comparing $1 million to $2 million. What would you rather have? You know, unless you're a philosopher or doing other kinds of being very clever, it's apparent that the answer is $2 million is better than $1 million. Now let me enrich the scenario. Suppose that yesterday you were worth $500,000, and today, lo and behold, thanks to the market, you're worth $1 million. Compare that to yesterday you were worth $4 million. And due to the market today, you're worth $2 million. Which person would you rather be? The one with $1 million or the one with $2 million? I'm not sure that everybody would say in this case $1 million, but there is experimental evidence that lots of people say in this case, I'd rather be the first person. In other words, it turns out that it doesn't just matter how much you have, it matters how you got there. Now, that's called path dependence, and path dependence violates an assumption of economic theory, a common assumption that claims that it should be independent of path. It doesn't matter how you got there, it matters what the final position is. So I would like to give you one of the most let me say the following. So until prospect theory, which I will say a word about in a minute for those who may not know what it is, the common exchange between psychologists or experimentalists and economists was that psychologists would point out some violation of the axiom, and economists would counter it as best they can or even embrace it into their theories, done on a piecemeal basis. And one of the most famous exchanges of this kind was done between Allais and Savage in one of the early conferences on utility theory, and I will give you a simplified version of their exchange. So I'm going to ask you a question, which when I have an audience large enough, I collect data on, because it's one of those things you can rely on to always replicate, but the audience here is too small, so each one of you will just have to ask himself or theirself what their preference is. What do you prefer? $700 for sure, right now, payable in cash, or an 80% chance for $1,000. Think about it. And if you're like the majority of subjects, you'd rather have the $700 than the gamble. Second question, what do you prefer? A $700 with a probability of 25%, 1 in 4, or $1,000 with a probability of 20%, 1 in 5. Think about it. And again, as I tell my students, it's not about whether I'm going to cheat with the probabilities. Bring your lawyer, bring your own chance device. I mean, check that I have the money. Nothing here should be about that. Again, if you're like a majority of the subjects, you prefer $1,000 with a 1 in 5 chance than $700 with a 1 in 4 chance. So did Savage. This was Allais' example, and Savage answered as most subjects do. Now, Allais pointed out that this violates utility theory, that this is inconsistent. Now, how can Savage do something inconsistent? I will now reframe the second choice problem for you. You have a 25% chance to face the following choice. The choice being what I asked you first. So it's now a two-step move. First of all, participate in a 1 in 4 lottery. You lost it, bye bye. You won, you are now in a position that you can answer the question, would you rather have $700 for sure or $1,000 with an 80% probability? Now, again, most people say, you already asked me that question and I already gave you the answer. I'd rather have $700 for sure than $1,000 for with a probability of 80%. But notice that the question, in fact, is question number 2. It's not $700 for sure. It's $700 for sure if you pass a 1 in 4 lottery. So if you choose $700, it's a 1 in 4 chance of getting $700. Now, Savage went home, according to the legend around this story, thought about it, came back and said, indeed, I erred. Indeed, the preferences I gave you are not my true preferences. I will think about it carefully, which of these 2 things I prefer, the gamble or the sure thing. But once I know, I'm going to give the same answer to both questions. Now, he may have thought his way out of the trap that Allah set for him, but he in fact gives thereby an example of a different kind of setup, if you will, and that is the one that says frames matter. In other words, how you think of a problem, how it's presented, the words, the terms make a difference. Now, there is no axiom in economic theory that says frames don't matter, because there's, as philosophers of science point out often, not everything in the theory is explicitly stated. Some things are too obvious to be stated. And one of the things that economic theory doesn't even think is worth mentioning explicitly is invariance to frame. Economic theory says that people choose between options. Psychology says that people choose between descriptions of options or presentations of options in the case it's not a verbal question. So how something is presented may affect choice, even though the options themselves haven't changed. One of the most famous examples of this kind, you may have heard about it, goes as following. It's called the Asian disease story, but I've been told that Asian disease is no longer politically correct. So forget Asian disease. It's a flu. So a flu is expected next winter, and deaths are expected to run at 900. And you are prime minister, and what do you do about this dire prediction? Your health minister offers you a choice between 2 programs which you can adopt. If one is adopted, it's a certainty that 600 lives will be saved. One way to think about the story doesn't tell you how a scenario like that would come about. That's the beauty of hypothetical questionnaires. You can just invent whatever you want, but you may think of the existence of some kind of foolproof cure that you only have enough to administer to 600 people. So if you use it, 600 people will be saved. The other one is uncertain. The other one, you have enough to give everybody, but there's only a 2/3 probability that it will work. So with a 2/3 probability, you save everybody. With a 1/3 probability, you save nobody, and that is now your choice as prime minister. Again, it turns out from empirical evidence that that when the story is told this way, most people prefer to save 600 lives than to take the gamble. But now you turn it around and you ask preferably different people so that they won't notice explicitly the move I'm going to make now. Instead of saying that the first program will save 600 lives, it says that the first program will result in the death of 300 people. Now, if you do nothing and it's 900, and you do program A and it's 300, you've just saved 600 people. But that you don't say it in so many words. You say 300 will die. And the second program, you say with a 2/3 probability, nobody will die. And with a 1/3 probability, everybody will die. Everybody from what? Everybody from the projected 900. And now, lo and behold, as is known from already from prospect theory, now people prefer the gamble to the sure thing. Now, surely preference can't be reliant on the words chosen to present the outcomes, but rather on the outcomes themselves. However, psychology shows that this sure thing is not a sure thing. In fact, since I knew Tversky personally, he was a friend and he was my mentor and he was my PhD advisor. I remember him once saying to me, any axiom that an economist will put forth, I can put forth an empirical counterexample, especially if I'm allowed, as I am, to vary frames. So you can't get people to be consistent if they respond to the way you present outcomes, and I can choose how I want to present them. Now, prospect theory, which I will not go into now for those who don't know, but it was what won Kahneman. Tversky was dead by then, the Nobel Prize in Economics, was revolutionary in the following sense. It didn't just present piecemeal counterexamples to this claim or that claim, but rather it was a systematic mathematical axiomatization of what they called of value theory, of the subjective counterpart of utility. And moreover, it was published by two psychologists in Econometrica, one of the leading journals in economics, and it was in fact the doorway through the work of these psychologists in particular and of other psychologists in general. That was the doorway into economics, what was the Nobel Prize, and since then even neuroscientists like Elizabeth Feld do what you call a behavioral economics experiment. So Kahneman once said about prospect theory, which, as I said, got a Nobel Prize in economics, and which I'm not going to go into the details of, but he said about it, and you might be surprised, he said it's a theory about nothing. Now, what did he mean by saying it's a theory about nothing? When asked, he will say the following, which is true. He says, it's a theory about binary choice, meaning the need to choose just between two things, not more, which is often the case, each option of which is a binary gamble. In other words, each of which has only two possible outcomes, unlike many things in the real world that have many possible outcomes, which are monetary. Lots of things in the real world are between things like lives and time and quality of life, monetary with known probabilities. And then he says, now how broad is that? So by nothing he means it's a theory about a very, very narrow kind of choice. So it's not prospect theory that is important. It's some of the insights in prospect theory that go way beyond binary choice between binary gambles with monetary outcomes and known probabilities. And the ideas, the core ideas are people are sensitive not to final positions. They are sensitive to changes in final positions. Just like in psychophysics, this is true for perceptions of weight, luminosity, duration, lots of physical variables. Their subjective psychological counterpart is sensitive to changes in position, not final position. Changes are with respect to a reference point. The reference point could be set from outside. The reference point can be where you presently are, that you have been sitting here for enough time that you are now adjusted to the temperature in this room, the luminosity in this room. This may be your reference point. Changes from a reference point you are more sensitive to changes for the worse, called loss aversion, than to changes for the better, gains. And in my mind, in a sense, most critically, you're sensitive to frames. So this is way beyond the nothingness of prospect theory. Now, prospect theory only addressed the von Neumann Morgenstern theory of choice under uncertainty, Of course, economics deals with lots of other things, and so does psychology. And I will mention two of them just to give you headlines, not that I can go into them, but two really important things that economists need to deal with and figure majorly in behavioral economics are weakness of the will, otherwise known as self-control problems. In other words, we may know what our preferences are. We may wish to maximize something. We may wish to choose A, and lo and behold, we end up doing B. Why? Because we're human. I mean, this happened to Adam in the Garden of Eden, and it accompanies humankind ever since. And the other major problem is noise, a technical term which means no more and no less than inconsistency, and which Kahneman recently published with two colleagues, Oliver Siboni and Cass Sunstein, a book about called Noise. And noise, says Kahneman, he says, I assume responsibility for the fact that error in judgment is so closely identified with biases when a much greater source of errors in judgment is simply inconsistency or noise. So these are, again, two psychological facts that any economist who wants to not just do mathematical models, but actually make economic predictions must take account of. Now, how much time do I have left? Do I have time to address nudge, or should I go to my conclusion, which I can do now? So can I have a few more minutes, Viviana? Then I will say a word about nudge. So one of Thaler's best known contributions to behavioral economics is the idea of nudges. What are nudges? Nudges are very small interventions in choice architecture. In a minute, I'll say what that is, that may have far reaching consequences. What is choice architecture? Choice architecture is the context in which choice takes place. If it's an experiment, then choice architecture is the words that the experimenter uses in presenting the problems. In the real world, it's where are you, what is going on when choice is being made, and uh, and and nudges is another important word in what I said is that nudges may have far-reaching consequences. It's become very commonplace to think, since nudge came into being, that there is a simple, simple, painless, costless intervention to cure just about everything. I was called many times in 2020 and 2021. I was called by the media as an expert behavioral economist, which, if you recall, I said in the beginning, I am not, if I could solve the problem of reluctance to be vaccinated. Is there a behavioral economic cure for it? Is there some small little intervention we can do, and lo and behold, all the people resistant to vaccinations will come and get them? Well, nudges work when they work. Unfortunately, in the real world, it is true that there is a positive correlation between cost and benefit. And if you want to have large effects, you often have to put large investments into it. But how wonderful it is that this is not always the case, that there are, in fact, cases, and their book is full of them, where small interventions can have far-reaching effects. Perhaps some of you have heard the embarrassing story of reducing insurance fraud by getting the person making the insurance claim to sign to the fact that everything written in the claim is true, not at the end of the claim, but at the beginning of the claim. Sadly, it turns out not to work, not to be effective, although many insurance companies adopted this idea because it's costless to adopt. But had it worked, imagine how nice it is if you can reduce insurance fraud just by moving the place on the form where you sign and say, everything I said here is true. So there have been very nice achievements with the idea of nudge. On the other hand, it's given many people a misconception of what behavioral economics is about and what it can do. Now, I'm going to conclude my talk and go back to the little clip I showed you at the beginning. This little clip, I summarized it for you, but now I'm going to add something that's pertinent to my point. The law that says that free fall is independent of mass is true in a vacuum. And on a clear day when there's no wind and you drop 2 balls from the Tower of Pisa, air resistance is close to what it would be in a vacuum, especially if the 2 balls are of equal shape. The intuition that guided Aristotle and everybody after him for 2,000 years was something like, what if you drop a feather from the Tower of Pisa or a piece of paper from the Tower of Pisa, and then we don't have to run the experiment. We can do the thought experiment. It won't reach the ground at the same speed as a metal ball. But that's air resistance. That's not free fall. So in the real world, there is friction. In the real world, if you want to push a heavy object a large distance, you will need to invest more effort if the object is heavy than light, and if you want to push it a long distance than short. But in a frictionless world, you can give a ball a little shove and it will go forever and ever. That's inertia, because what stops it is friction. And I just said frictionless world. We don't live in such a world. But we can, and behavioral economics sometimes attempts to do that, we can sort of reduce friction. So one way of pushing a heavy ball a long distance is by smoothing the surface rather than by investing more effort in doing so. So my conclusion is I would like to point out that of all the various ways that people have tried to reconcile behavioral economics with mainstream economics, my personal preference is to consider the relationship between them the same as the relationship with physics in a world with friction and physics in a frictionless world. So are they competing with each other? Not really. Do they need to be reconciled with each other? Not really. One should just realize that high school physics pertains to a different world than the world we live in. The world we live in has friction in it. If you want to send rockets to the moon, if you want a car to run, if you want machines to run, if you want anything to happen in the real world, you better take account of friction, even though you shouldn't forget high school physics. Likewise, I would say the difference between mainstream economics and behavioral economics is not that they are competing with each other. It's not that one is right and one is wrong. Neoclassical economics is about that hypothetical creature called Homo economicus, which Dick Saylor calls econ, a fully rational being. And behavioral economics is about Homo sapiens, which is the kind of homo that we all are, and subject to all the effects I mentioned. I will repeat them: weakness of the will, inconsistencies, overconfidence, heuristics and biases, to mention just a few of the things. So they are different theories that pertain to different homo, and they are not necessarily in competition. You want to do economics in the real world with predictions, you better use behavioral economics. You want to do beautiful normative theory with elegant mathematical models, you can't beat neoclassical economics for that. Thank you.
Well, first of all, I would like that the word homo would be changed into womo with a W at the beginning. But aside from this, I was wondering about your nudgets. If in that sentence and the top of the questionnaire, it was written, if you lie, you lose your insurance, how much that would change what you are writing. So if it is only put at the beginning, the same sentence, it might not change a lot. But if you put a loss, like you're losing your insurance, probably people would be, and I'm going back to what also Elizabeth was saying, the fear of loss, that might induce people to be more honest. Do you agree?
So here is my answer. My answer is, if you want to know the answer, run a study. So you gave a reason why one might hypothesize it. It might sound to an economist like a crazy idea, because everybody knows that if you lie to your insurance company and they catch you, you forfeit the insurance. So why would an economist might say, why would writing it down matter? And you would say, because of everything we know about psychology. And I would say, you're absolutely right. Let's run a study. We won't know the answer unless we study it.